Very good morning, class. In the previous video, I have done some basic concept about the graphical representation in the motion in one dimension. I told you how to calculate the velocity or the acceleration or the displacement from these graphs. I told you there are basically three kinds of graphs. First, we have displacement time graph, velocity time graph, and the acceleration time graph. And there are some cases in these graphs further. So today I will discuss these graphs because in exams some numerical will definitely come from this topic. So let's start the very first graph, which is displacement time graph. Displacement time graph. Okay. The first case of graph, we can say case 1, when body is at rest. Body is at rest. That means time is increasing, but body is not changing its position. Suppose, let's say this is the origin point, right? And I'm standing here, and I'll keep standing here for, let's say, 1 minute. So that means time will move on to the from 0 second to 1/20th second, but I'll not change my position, and I'm at the origin, right? So what will be the graph? Graph will be like this. Here we have displacement, and this is time, right? This is the origin. So I'm keep standing on the origin O here. I'm not changing my position. So simply the graph will be a blank graph will be there. There will be no line, because obviously I'm not changing my position. So there will be no, we can say we don't have any information about displacement, right? Also we can describe this graph in one more way. Suppose I was here and I covered some distance, I stand here, right? A person climbs up at the roof of a building, right, which is, let's say, 10-meter high, and it stand on the roof of building. Then the time started, right? I have counting the time after he reaches at the roof. That means he will cover 10-meter distance. He reaches here, and as soon as he reaches at the roof, now the time has started. So now the time is increasing, but it is not covering any more distance. So the graph will be this. It will be a parallel line to the x-axis, which shows there will be no displacement further, right? This is the displacement. We can say this is the initial position of the body. Body was already placed at some height or at some distance from the origin point, right? So this is your first case when the body is at rest. Now, if you remember, I made a table. In that table, I told you that the slope of displacement time graph shows the velocity of the body, right? So what is the slope of graph here? Here, slope is 0. Why? What is slope? Slope is del y by del x. So you can count, we can find the value of del x here, but you can't find the value of del y here because y is not changing. That's why slope is 0, and slope is 0 means velocity is 0. That means this velocity is 0. It means satisfying the case which is body it is at rest, right? So now let's see what is the next case of this graph. The next case will be a body is moving with uniform velocity, right? So let's check how we can make the graph of this case. Case 2, body is moving with constant velocity. One thing, whenever you made these graphs, keep mind that what the slope of graph represents, what is the area under the graph, right? Now in this case we know that the velocity of the graph of the body is constant, and you know that velocity of the body represented by the slope of the graph, right? So here in this case we know that velocity is constant, and velocity represents what? It represents slope, right? That means the graph must be like that, in which we have a constant slope which is not changing, right? So it will be like this. You can check slope of this graph between any 2 points and you will find the slope will be constant. All right, so this is the second case. Now what will be the third case? Okay, so let's find the third case. First case was velocity was 0, second case velocity is increasing, velocity is constant. Third case can be velocity can be increased or velocity can be decreased. That means velocity is changing. So let's do both of the parts, increasing and decreasing. Okay. So case 3, part A, I am dividing this case into 2 parts. First A, when body moves with constant acceleration, that means velocity is increasing, right? What can be the next case here? Body is moving with constant retardation. It means velocity of body is decreasing. Velocity is decreasing. Okay. How we solve this graph? Okay. Velocity is represented by slope. Now velocity is increasing, so it means that the slope of the graph is also increasing. So what can be the graph? It will be like this. You can check at any 2 point, between any 2 point, the slope of the graph is not constant. It is in the form of curve and it keep on increasing, right? Body is moving with constant acceleration, retardation, that the body velocity is decreasing. It means the graph it will be like this. Now here you can see that the graph is becoming parallel to the x-axis. See, I'm saying that suppose you push a body, let's say you push a trolley up by applying some force on it. So as you push, it start moving, right? And as it moves, there will be some friction between the wheels and the platform on which the trolley is moving. So after covering some distance, the velocity of the body will become zero, right? That means body will comes at rest. Now, if you remember the first case, when the body is at rest, what was the graph? Graph was like this, parallel to the x-axis. Now, in this case, when the velocity of body is decreasing, that means we are moving toward the first case, where the velocity was zero, right? Because if a body is constantly moving with some constant retardation, so obviously one time will come after which that the velocity of body becomes zero. That means body will come at rest. Now you can see here, this graph is actually going to that condition. You can see the graph is becoming parallel to the time axis, right? So that's how you can find the this graph. Suppose you have to find the velocity between any 2 points, what we can do, no problem. Suppose we have to find the velocity from here to here, right? Now you can see this is a curved line, so directly we can't find the velocity of the curved line, the slope of the curved line. Do one thing, join this with a straight line like this, okay? So now you can take 2 points on the time axis and 2 points on the displacement axis as well. So this will be T1, this will be T2, this will be S1 and this will be S2, and these 2 points is A and B. Now you can find the velocity between these 2 points A and B and that will be V equals to S2 minus S1 upon T2 minus T1, that is del S upon del T. So here you can find out the velocity of the body even in these curved form, okay? So these are the cases where we can find the velocity by the displacement time graph. One more thing, or sometime question comes like you have two graphs, displacement time graph, and the question is in which graph the body is moving with let's say greater velocity, right? Let's take an example of it. Suppose we have these two graphs. I'm making in the only one. So these are two graphs of body A and B. Question will be simple. It will ask in which graph or which body is moving with greater velocity. So you know that to find velocity from displacement time graph, what we'll do? We'll simply find the slope. And you can see here which line have more slope. Obviously you can see that the graph A, the line A is more toward the y-axis. So basically slope is equals to del y upon del x. That means slope is proportional to del y, right, and inversely proportional to del x. So if any slope is sharply increasing, that means if del x is too small and del y is big, that means slope will be more. So here you can see that if we take two times, first time take the time here and second time take the time here. So in this time interval, the A body becomes reaches that point here. But if you see about the body B, this time this body only reaches at this point, right? That means the body A is moving with the greater velocity. So just check the slope of the graph, right? One more thing you can find, and that is slope also represented by the angle tan theta. What is theta here? simply this will be theta, right? So sometime if it given that the angle let's say give the angle 30 degree, find the slope of the graph. So don't confuse, just find the tan theta and that will be the slope of the graph, which is velocity of the body. All right, there's one more case in this displacement time graph. When the slope of the graph is negative, what does it mean? Suppose this is the displacement time graph. Now what do you understand by this graph? When time is 0, it was at some height or distance, anything, and when time increases it is moving downwards right? And you can see the angle between the x-axis and the line is more than 90 degree. So if you check your trigonometrical table, you will find if we move above 90 degree in 10, the value will start, the value of 10 above 90 degree is negative. That means the slope of the graph is negative here. So here slope is negative, which represent velocity. That means velocity is negative. Now what does it mean? How the velocity can negative? See, basically velocity is a vector quantity and the sign positive and negative basically show their direction, right? Whenever the graph, the displacement time graph, the slope is negative, it means that body is moving to its initial position. Then the velocity will be negative, right? How? Suppose I have started my journey from point A to point B, right? So when I move here, my velocity will be positive, and when I move backward here, my velocity will be negative, and that is why the total displacement will be 0. You can check here, when this body reaches here the displacement becomes 0. So velocity, negative velocity just show the direction, right? Okay, so this graph means the slope is negative, so velocity will be negative. Okay, sometimes the miracle comes like this. Like this, it will be let's just divide into some part. Let's say O, A, B, C, D and E. It says find the velocity between O and A, or AB, BC, CD, right? So you know what to do. To find the velocity from displacement time graph, find the slope of the graph, right? So so today we have done displacement time graph. In the next video I'll cover the velocity time graph, right? And we'll check what are the basic cases in the velocity time graph, and in the last part will be the acceleration time graph. Till then, thank you so much class.